Welcome everybody. In this video, we're going to look at dividing polynomials, and that's going to include things like long division of polynomials. So let's start with the beginning example. And in this case, you are dividing, but you only have a monomial here that you're dividing by, meaning that it only has one term. There's no plus or minuses. So your problem basically looks like this. So you have 6x cubed minus 3x squared plus 2. And it's being divided by 2x squared. So if you're dividing just by a single term, right? So this is a monomial, it's a single term. We don't have to do long division here. What we're going to do is actually just separate out the terms and simplify as much as we can. So this is the same as having 6x cubed over 2x squared minus 3x squared over 2x squared plus 2 over 2x squared. And then what we're going to do is just simplify each fraction individually. So for the first one, 6 over 2, we can actually divide those both by 2, right? The 2 would cancel out, and then we'd have a 3 left here. And then for x squared and x cubed, each of those have at least 2 x's in common that we can cancel. So I can cancel the 2 from the bottom, and then if I cancel 2 here, I would have 1 left. So that first piece becomes just 3x. I don't need to write the first power in. Now for my second group, I can't really do anything with the 3/2, right? There's no real factor in common besides 1, but I do notice that x squared over x squared would cancel. Those are exactly the same. And then in this last case, I do have a 2 over 2, which could cancel. Just be careful though, you would always have a factor left of 1. So you do need something in that numerator. And we can write the problem like this. So if we wanted to divide out by a monomial and simplify that way, we could do that. We would just look at each kind of fraction set up individually and then simplify it from there. Now, what I really want to spend most of the time on is dividing by things that are not one term. And for our purposes, we're typically going to stick with things that are 2 terms or binomials. So you're going to notice in the next couple examples here, it's not just one term. I have 2 terms, x plus 3, 3x minus 2. So we're going to perform long division here. And it actually works very similar to just regular division with numbers. You divide, you multiply, you subtract, you bring down over and over and over again. Okay. So as a just quick reminder here, let's say you wanted to divide something like 206 by 4. Well, you would set up your division bar. 4 does not go into 2, but it goes into 20. That's 5 times. Bring down the next value. 4 goes into 6 one time. And then you're left with a remainder of 2. Now, if we want to use that remainder notation, you can either write it as 51 remainder 2 as your answer, or what we often do is we take that remainder and we put it back over our divisor. Now here I can simplify that into 51 1/2, and that would be my final result. So we're going to use very similar steps here going through long division with polynomials, where you're going to see how many times that polynomial will go into the first term. You're going to multiply, subtract, bring down, and kind of repeat this process over and over and over again until you finish the problem. So let's go ahead and set this up. We're dividing by x plus 3, so this is going to go on the outside of our division bar. And then inside we have x squared plus 10x plus 21. Now, instead of writing detailed steps here, I really just want to talk through a few examples. And what you want to do is use the leading terms to get you started. So when I'm looking at my division, I'm not focusing on everything at once. And even here with my divisor, I'm looking at this leading piece here. The other thing I want to note that's important is you do want to have your powers on the inside in descending order. So you want those exponents to be decreasing, right? 2, 1, and then your number at the end. That's going to be the easiest way for you to divide. So make sure you have, we call it descending or decreasing powers when you divide. So now you focus on the first 2, right? So what we want to think about is how many times is x going to x squared? And it's kind of weird to think about that with variables. So think about what you're missing, right? If I wanted to go from x to x squared, what would I have to multiply by there? Well, I'd have to multiply it by x. So you want to try to get the term that's going to cancel. And then we're going to distribute that x to both parts. So x times x is x squared, and x times 3 is 3x. Now remember, you're subtracting here. Okay. Now, if you find it easier, you can always use keep, change. So that subtraction, don't forget, has to go for all terms here. So you're subtracting the x squared and you're subtracting the 3x. So if you find that hard to remember, what you can do is change this and put those negatives right next to the numbers to help you remember. So x squared minus x squared is 0. It should cancel out. That's what you want, that first term to cancel. And then 10 minus 3 is 7. So you have 7x. And then we're going to bring down that plus 21. Now, again, when you're dividing, you're only looking at the first term. So I'm looking at x and I'm looking at 7x. And I'm thinking to myself, okay, what times x would get me to match this? Well, here, I just need to multiply by a positive 7. So I'm going to use positive 7 as my multiplier. And then I multiply through. 7 times x is 7x. 7 times 3 is 21. Don't forget, though, you are subtracting. So you're subtracting both that 7x and the 21. What happens here is both end up canceling and you have a remainder of 0. So if you have a remainder of 0, you actually have a perfect factorization there. So our answer here is that x squared plus 10x plus 21 divided by x plus 3 is equal to, and then your answer is up top. This is your quotient, x plus 7. And again, there's no remainder in this case. The nice thing is when you have no remainder, you actually have a perfect factorization. So as a little side note here, I know I didn't ask you to do this, but x squared plus 10x plus 21, you could actually factor. You would have this as one factor, and then you would have the divisor as the other factor. Okay, so just a little note here, factoring and division are very much related. So it's a way for us to break down that problem. Let's do another one. So here we're going to divide by 3x minus 2. So that goes on the outside. Now on the inside, notice that my polynomial is written backwards where the powers are not in order. So I do want to write my powers in order under the root. So my highest power is x cubed. So it's positive 6x cubed. Be careful of your signs. This is a minus x squared, minus 5x, and then a positive or plus 4. So if you're rearranging terms, just be careful. Make sure you have all your signs correct as you rearrange. All right, and now we're going to start our division. So remember, you're only focusing on the leading terms here. Don't try to do everything at once. So just think about, okay, I have a 3x and I have a 6x cubed. What would I multiply by to get to 6x cubed? Well, 3 times 2 would get us 6. And then if I had x and then x squared, that would get us x cubed, right? That would give me 1 here and 2 there, which would give me 3 altogether. So up top here, you're looking for that missing multiplier. And then you're going to distribute it down to both parts. So 2x squared times 3x is 6x cubed. That first term should always match because you want it canceling. And then for the second one, 2 times negative 2 is negative 4, and then the x squared. Now, don't forget you're subtracting the whole thing. So another way that we can do this is we can write the negative with the value, and then be careful if you're subtracting a negative 4, this actually changes to adding 4. So that subtraction switches all your signs over. The first piece is going to cancel. This would have a 1 in it, so negative 1 plus 4 is 3. So I have 3x squared left, and I bring down just the next term. Now we do it again, just focusing on the 3x, and this time 3x squared. So notice that the 3's match, but I'm going from an x to an x squared, so I'm missing an x squared factor here. or an x factor, I should say, to get to the x squared. So if I multiply that by x, that would match that first group. And then x times -2 is -2x. And again, don't forget you're subtracting the whole thing. So it's going to make your 3 negative, but it's going to switch that -2 to a positive. Your first term should always cancel. -5 plus 2 is -3x, and bring down the +4. Again, 3x and -3x. So the only thing I'm missing here is a negative sign, so I can use a -1 or a -1, right, to get that fixed. So if I do -1 times 3x, I get -3x, and then -1 times -2 is +2. Again, remember that you're subtracting the whole thing, so you actually will change both signs over. First term cancels, and then 4 minus 2 is 2. Now at this point, I have nothing left to bring down, so we're done. We're not going to, there's no like attaching zeros or anything like that that we have with other long division. So your remainder here is 2. And what we can do is we can write our remainder like this. So let's see, our 6x cubed minus x squared minus 5x plus 4 problem divided by 3x minus 2 is equal to, so you're going to write your full answer first. And then what you do, your remainder is 2. So we're going to add the 2, but just like up here, you have to put that divisor in as your denominator. So our divisor here is 3x minus 2. So that's how we would write our answer. Okay, so this part right here is where the remainder comes in. And then this part here is called the quotient. Okay. On the other example, we just have the quotient because we don't have any remainder. The remainder would be 0. So the quotient is that main division answer that you have. As a little side note here, you can still check your work. So in the first case, if you have no remainder, it's pretty easy to check. If you actually go ahead and take those two factors, so that divisor and the quotient, and you FOIL this all out, you should get the starting value there, or that starting polynomial. If you have a remainder, we can still check it, although it's a little bit different. So what you're going to do instead here is you're going to take that 3x minus 2. So you have your divisor and your quotient, and you multiply them together just like we did over here. But what you're going to do at the end is you're going to add in the remainder. So I'm not going to do the check here in the video to save time, but I encourage you to try it at home. So what you would do is you would multiply all this out, simplify that first, and then add in the 2. Notice that when I'm doing the check, when I add in the remainder, I don't need the denominator here. It's just the actual remainder value. That's actually how we check long division as well that has remainders. Here, you still have the divisor and the quotient. And the reason that you're not adding anything is because there is no remainder. So you don't need to put +0 there. But that's how you can check your work as well. All right, let's do one more example. So here we have this polynomial and we're dividing by 3x squared minus 2x. So whatever you're dividing by goes on the outside. And then on the inside, let's see, we're in order. So I have 6x to the 4th, 5x squared. Now notice that you are missing this time the x squared term. So if you're missing a term in your polynomial, I do recommend you putting in that term with a 0 in front. Oh, sorry, this is x cubed, I apologize. And then this would be 0x squared. Then I have plus 3x and minus 5. It's just helpful because when you start multiplying everything out, things have to line up with the correct like term. So if you're missing terms when you're multiplying or dividing, in this case, then you want to just fill in that missing term with a 0. Okay. You could do the same thing on the outside. So if you do have missing terms on the outside as well, like let's say this was 3x squared minus 2. If you want, again, you could put that 0 for that missing, let's say, x term as well. It just helps to keep things a little more organized as you're doing your long division and when you're multiplying out that quotient piece. Okay. All right, so let's look here. So I'm going to start with my leading terms. And those are the only two that I'm focusing on. So 3x squared and 6x to the 4th. And I'm trying to think of, okay, what am I missing here to get these to match? Well, 3 times 2 would be 6. And to go from x squared to x to the 4th, I'm missing 2 x's. So I would use an x squared term. Multiply this out, you get 6x to the 4th. And then here, 2 times negative 2 is negative 4. X squared times x is x cubed. We subtract. So again, if you can do this subtraction in your head, that's absolutely fine. I like to change my signs over. So I just make the 6 a negative and make the 4 positive. I think a little bit easier. So 6 minus 6 cancels, and then 5 plus 4 now is 9. Okay. Now, there's not really anything to bring down here, but you can go ahead and just bring down that next term. Okay, so I'm going to bring down that plus 0x squared. And again, I know it seems a little silly because it's just a 0, but it just helps us to stay organized and line everything up. So now you're comparing 3x squared with the 9x cubed. So 3 times 3 would be 9. And then let's see, I have x squared to x cubed, so I'm missing an x term. When I multiply this through, I have 9x cubed. And then 3 times 2 is negative 6. X times x is x squared. So you can kind of just see why I brought the next term down and left it as a 0. It just helps me stay more organized. And then I have a positive 6x squared. Now I bring down the plus 3x and I repeat the process, 3x squared into 6x squared here. So I'm only missing a factor of 2. 2 times 3x squared is 6x squared. 2 times minus 2 is negative 4, so negative 4x. So I'm left with a 7x here, and then I can bring down this minus 5 as well. Now, when we get to the last step here, you would keep going, right? Because you just brought something down. So we want to naturally say, okay, well, 3x squared into 7x. But there's a slight problem here, and that's that my degree is smaller than my degree here, right? So here I have an x and here I have an x squared. So it doesn't make sense for me to try to find a factor to go from x squared to x. I'd have to do some sort of division there. So if you hit that point in your dividing where your next term now has a smaller exponent than your divisor, it's time to stop. So that's going to be our remainder here. So our remainder is actually 7x minus 5, which is totally fine. So our problem was 6x to the 4th plus 5x cubed plus 3x minus 5. And we divided that by 3x squared minus 2x. And our answer was 2x squared plus 3x plus 2. And then don't forget your remainder, plus your remainder, 7x minus 5. And that remainder goes over your divisor, whatever you're dividing by. Okay. So again, you can kind of write your answer this way if you just need the quotient and they just want the remainder without putting it over the divisor. But if you're actually asked for the full answer, it would be this plus your remainder. So that would be your final answer here for the long division.